Hello, welcome to software testing methodology. So today I am going to discuss about the topic is logic based testing. So what is logic based testing? Before that, what is meant by logic? So logic is nothing but a word which is mostly used by the programmers, and logic is nothing but a condition which is to be performed the action or the satisfying that condition with two or more actions to be performed like yes or no. So the Boolean algebra expression is said to be logic in its simplest form, like a less than b or a greater than b, a equals to b. That condition is satisfied, then action will be performed. And the testing that is performed on the Boolean algebra, nothing but the testing that is performed on the logic is nothing but logic based testing. So what are the steps that are to be considered? Or hardware logic testing, specification systems, knowledge based systems. These are all the steps that are to be considered. So hardware logic testing, specification systems, knowledge based systems. So what is meant by hardware logic system? Generally, it is a primary tool for designers. Whatever the designers should perform the primary tool. So this is the way to define the primary tool as a logic based testing. Generally, the automation of software testing is done 10 to 15 years before the automation of software testing. So before the software testing, there is 10 of hardware testing will be done before 10 to 15 years. So specifications, here is the specification system, which is a major problem with the specifications. Mainly it has a major problem with the specifications like hardware specifications and software specifications or requirements, is that they would be hard to express. It is totally hard to express. To understand these specifications or rejection of specifications, the Boolean algebra should be known. So whatever the Boolean algebra we have taken to understand that specifications about that or rejection, whatever it may be. So what the expression, nothing but what the Boolean algebra expression can be known. So in this is one of the steps to be considered in the logic based testing. So another step is nothing but knowledge based system. Every programmer or every designer should have the knowledge about so and so software application that all need to be developed. So in that knowledge, it is mainly used to construct many applications which are very difficult. So whatever the difficult applications to be constructed, to be built, to be designed, and these systems will gather knowledge from a knowledge repository or a domain into a database. So by using these systems, whatever the large system we have going to define, implemented or designed or constructed, by that system there is the gathering of knowledge. So these are all the three steps to be considered in logic based testing. So next we will discuss about the decision table. What is the table? What is this table? Generally, the name itself tells the decision table consists of all the decisions, all the predicates. Predicate means condition is nothing but decision. So the table which consists of set of conditions and corresponding actions is known as decision table. So every condition needs some action. Like S means some action, no means some other action will be performed. So this table consists of set of conditions and corresponding actions is known as decision table, and this table consists of four areas such as condition stub, condition entry, action stub and action entry. So this is the decision table which defines as a condition stub, condition entry, action stub and action entry. So first, what is meant by condition stub? Condition stub, a list of names of conditions is known as a condition stub. All conditions can be grouped into together and performing as a list. It is known as a condition stub. Every column in the table specifies some rules. So whatever the rules to be specified, that rules to be followed. If the condition followed such type of rule, then the action will be performed. For these rules to be matched, conditions are marked with yes or no condition. If the condition is yes, then it specifies should meet the particular rule. If the condition is no, the rule will not be met. So this is about the condition stub. Next, the another aspect in the decision table is condition entry. So the name itself, the entry of the condition, all the rules of the columns of decision table consists for the rule, that is the rule has to be satisfied by the condition or not. So this defines the condition entry. Next, coming to the action stub. Action stub also consists of all list of conditions, actions, list of actions. Like as condition stub consists of list of condition, action stub contains list of actions. So this is the action stub, and action entry means same is as well as action entry. The name itself tells. So yes or no. If the action is yes, then the action will be performed. If the action is no, then action doesn't meet the rule and the action doesn't perform that operation. So this is the decision table defines four aspects, condition stub, condition entry, action stub and action entry. So next coming to the applications. What are the applications of the decision table? Where the decision table uses. Mostly decision table uses in the table processors to be defined the processor. Decision table for test case design. If there is any immaterial cases to be expansion and decision table and the structure can be defined. So first one is decision table processors. So the decision tables are mostly used in business data processing. Mostly business data processing as a soft copy, to access the soft copy, to define the soft copy, to implement the soft copy. This decision table processes mostly used in business data processing. Hence they are known as, that processing is known as, that processors is known as decision table processors. So here the translator will automatically convert the decision table into source code in high level language. So in some companies, in some business organizations, they need to convert the decision tables, whatever conditions and actions to be performed. That decision table is converted into source code as in high level language. So that is the way to define the decision table, and the translator would check the rules first. Whatever the first rule or second rule, whatever, if the rule 1 is satisfied, then the corresponding action of rule 1 is to be performed. So this is the decision table processes, and the process of checking rules is done until all the rules in the decision tables are checked. So this is the way it defines some of the decision table processor application, and they also have some advantages and as well as disadvantages. So first advantage is integration of clarity. So clarity should be integrated, combining of all the decision table like conditions, actions, clarity is defined. So and explicit relation to specification. So whatever the specification we are using, so all the explicitly related can be done between those specifications. Next, high level maintainability. The maintainability will be totally high level. High level maintenance will be defined. So that is one of the advantage of decision table processor. Next, coming to the disadvantage, insufficient program providers. So the only one and only disadvantage is nothing but decision table processors define insufficient program provides. So that is now one of the disadvantage. Next, coming to the decision table for test case design. So the decision table should be used for test case design when decision table acts as specification. So whenever we need to define the specification, that decision table is used for test case design. So first design should be done. That is one of the way to define the decision table for test case design, and these are all used as basis for designing test cases when logic of program is implemented. Mainly it depends on the logic. When the logic of program is implemented, then they are used for basis for designing test cases. So next, coming to the, even if the decision tables are given as programs logic, it will not be possible to implement. So whenever, if we take the decision table as the program's logic, mainly the logic condition of the program condition or program code, so it will not be possible to implement it. So that is one of the case to define. This is because of logic behavior, that is, it may contain interfaces or restrictions, and it may not have sufficient features. So this is a way to define the decision tables for test case design. Next, expansion of immaterial cases. First, what is meant by immaterial cases? It is nothing but a immaterial cases is nothing but a no operation, performing no operation, nothing but doesn't play any role. The whatever the entries defines in the decision table in which the condition doesn't play any role will define the I. I is nothing but immaterial case, nothing but performs no operation. It means the condition doesn't affect the action whether it is either true or false. It is denoted by I in decision table. So either true means true or false means false. It is denoted by I in decision table. It is an immaterial case. So the expansion of immaterial cases is done by replacing each I entry in table with a pair of cases or entries. So this is about the expansion of immaterial cases. Next, coming to the decision table and structure. So this is the structure of decision table. It is the main purpose of decision table to check the structure of a program. It can be represented in the form of a decision tree where combinations of conditions, actions and different actions will be performed to give some expectations. Like see this decision table. So it consists of R1, R2, R3, R4, R5, R6 are the rules, and condition C1, C2, C3, C4, action A1, A2, A3, A4 or some other. All is nothing but a consists of decision table like conditions, actions and rules. So yes or no is nothing but action. If the rule is satisfied, then yes. If the rule is not satisfied, then it is no. If the rule of condition so and so condition doesn't play any role, it is a I, nothing but immaterial cases. So nothing but it performs no operation. So this is about the decision table and structure. So see this the flow graph. This is the flow graph which defines the conditions and actions to be performed. So one is an entry node which defines. So this is C1 is nothing but a condition. So C1, C2, C3 all these are all the condition. Action 1, action 2, action 3 are the three actions to be performed, and 2 is nothing but exit node. So R1, R2, R3, R4 these are all the rules, and if the C1 satisfies S condition, then it again checks the C3 condition. If it is no, then again it will goes to the C2 condition. If it is yes, again it will goes to the C2 condition 4. So if C4 here C2 is S, then it will go to the performing the rule 2 and action will be generated. So this is about the flow graph which defines. Next, coming to the path expressions. What is meant by path expression? We have already discussed it in the previous chapters. So path expression is nothing but it can be depends on expression which comes from the following ways, like nothing but predicates, binary values, binary truth values, Boolean algebra, Boolean algebra. So here also one of the way to define reducing Boolean algebra. So what is meant by path expression? I already discussed in the previous chapter. Expression which defines which rises between the entry node and exit node, it is known as a path expression. So predicate and binary truth values. So what is meant by predicate? The process whose outcome is a truth value is known as a predicate. Truth value, you all know about the truth value like T and F. T means true, F means false. So the predicate is based on relational operators include greater than, less than, equals to, greater than or equals to, less than or equals to, etc. So that is the predicate. Next, what is the binary truth values? I already told that it is a true or false. If the action is performed, true. If the action is not performed, false. So it has a immaterial way, like no operation will be performed. And it has some of the true or false such as multi-way logic and multi-valued logic. Multi-way means defines the multiple ways to be performed of the action. Multi-valued means the value will be defined in the number of ways. So that is the multi-way and multi-valued. So here we'll take the Boolean algebra which deals with true and false values of the predicate. Whatever the condition is defined, if the condition is satisfied, the true will be defined. If not satisfied, the false will be performed. The true and false values of the predicate sometimes indicate as 1 and 0. So Boolean algebra will take the binary values like 1 and 0. It may use three operators like multiplication, addition, negation. So nothing but into or and, plus or a means a minus means negation. So that is nothing but binary truth values. So this is the truth table for multiplication. So see this a b. So a consists of four possibility ways like t t f f. B consists of t f t f. A cross b means true means true. Rest of all false. So you all well known about this truth table. And this is the truth table for addition. So same, if the A and B are false, then it is false. If the both like true, all these are all the true. So that is nothing but A plus B. So next coming to the truth table for A bar. So T means F, F means T. So this is the way to define the truth tables like multiplication, addition and negation. So associative law, here we will follow some laws like see this law, a plus b plus c is equal to a plus b plus c. So this rule, this law to be satisfied like a plus b means all, false means false, then rest of all true. So this is the truth table for this associative law of addition. So this is the addition. Next, same associative law of multiplication, following same multiplication rule and performing the truth table for this, and this all whenever the all true means it is a true, rest of all false. So this is about associative law of multiplication and addition. Next, distributive law of multiplication, distributive law, a plus bc is equal to a plus b into a plus c. Sum of products is equal to product of sum, like. So this is the truth tables for that distributive law of addition, so sum of products and sum of the products with sum of rules. So this is about the truth table. Next, how to reduce the Boolean expression. So this is the very easy one, removing the parentheses by multiplying all the necessary variables. So if you take, this is the condition which to be satisfied. If any identical terms are there, replace all the identical terms by one term. Like see this a b bar c plus b d bar plus a b d bar and plus a bar c. So this a b bar c plus b into, so we can write like this in this way. So by simplifying all in this way, we can access this type of Boolean expression like b plus c. So we can reduce all the Boolean expressions by using flow graph, whatever the conditions, whatever the actions, whatever the rules to be satisfied with binary truth values, with binary tables, truth tables using multiplication, addition and negation. So this is the way to define the logic based testing. So hope you all understand about this logic based testing. So thank you very much.